Thank you for joining this webinar. Just a brief background about myself, and then I'll introduce the presenter. So I'm Andrew Smales. I'm the Director of Radon AI, who represent expert.ai in Australia. I've been working in sort of data management, structured data for 30 odd years, and it's about 10 years since I became interested in looking at, how do you extract information out of unstructured data. And that's how I came across expert AI. It's basically because especially government departments that I work with, many other organisations have a large amount of unstructured assets that weren't currently being leveraged. So I'd like to introduce Nico Larini, who is from Verona, Italy, and he's worked in unstructured data for 20 years, and at expert AI since 2006. Where he is the chief scientist. He has worked at text analytics and NLP since then, and first designed and managed new software technology like the Cogito platform. He then helped the company grow, following strategic customers, and helped them implement the best artificial solutions for their business. In recent years, he's been leading the internal cross-division group dedicated to researching, improving, and adopting the best technology tools and models in the generative AI area to make the integration of these tools into the business solutions powerful, safe, and effective. So I'd like to introduce Nico and pass you on to him.
Okay, so yeah, let me start. So the point is, we're going to talk about our implementation of a large language model in the business context to customize the existing foundational model and get something that let us be more effective in specific industries. So we've been adopting large language models for more than a couple of years now, and I'm going to tell you our experience in having a specific customized version of a LLM that is worked on by us and that is proposed to our customers. One of the main points is related to a smooth and a safe integration, because it's something which is very powerful but also very complex to deal with. Okay, so let me start. The agenda for today will be, first, let me just talk about expert.ai very briefly, to mention what we do and who we are, what we do, and for what customers in what industries. That will be a very short presentation. Then what we do for the AI research in general, because we are not just adopting existing technologies, but we have been developing our technologies for years, and the same thing is what we do for the generative AI area. Then I'll be mentioning the underlying reason for which we decided to customize and adopt an LLM and not just use the existing technology, but work on specific tuning of models, and what we obtained and what we are still obtaining. Then how we are using it, a couple of examples of using a specific LLM and integrating that in a framework that lets us deliver projects and solutions that exploit the generative AI power. Yeah, and finally, some example of applications that use this framework and deliver effective results to our customers. Okay, so let me start with a short presentation of what expert.ai is. We are an international company. We were born in Italy like more than 30 years ago, and today we are present on several markets from across the most important countries in Europe, to the US, to Australia, and we are listed on the stock market in Italy. So like we've been listed for like 10 years. We work in artificial intelligence. We've been always working in artificial intelligence, even when it was not called like that. It was not generative AI. It was made with other technologies, but we've been always working with these solutions that can deliver ROI to our customers in understanding the content of their documents. Of course, the technology changed a lot over time. Our customers changed a lot over time. What we did has been changing a lot, because this is an area where technology is changing very, very quickly. So as I said, we started a very long time ago for a software company, and we started by creating basically spell checkers and grammar checkers for Microsoft Office at the time, for some languages. All of our technology was purely linguistic at the time, and we started developing our symbolic technology with a knowledge graph, which is something that is considered very modern, but we've been doing that for more than 20 years, more than 30 years, sorry. We moved across the years with a lot of solutions and a lot of customers going from Italy to Europe to the world. In fact, we expanded our markets and also our offer. We've been, as I said, listed on the stock market for like more than 10 years now, and we moved from the symbolic technology to machine learning and database technologies when they became productive, having even more important customers. So from government agencies like the FBI, for example, to Dow Jones, to a lot of insurance companies like Zurich or others, to Lloyd's of London. And we've been moving across verticals, across industries, but especially where these industries have the document problem. So having many documents and being able to understand the content of their documents. So we developed our hybrid platform, that is hybrid because it combines multiple technologies in a single framework and platforms, until we got to today, where we got new customers and we moved across the new technologies, adopting also generative AI, and always working on the cutting edge, trying to predict what will be the best technologies in the next months and years. So what we sell today is what we've been developing in the last years. The industries in which we work are multiple. So in this case, let me show you briefly what are the most important ones. So insurance is one of our most important insurance areas, where we have a lot of customers, but also related industries like finance and banking is important. Healthcare and pharma, where we work with basically pharmaceutical companies in general, but also other more scientific companies that are related to healthcare, or media companies like publishers and information services, or manufacturing utilities like energy companies, but that is mostly in Italy. And as I mentioned, also government agencies, intelligence, and companies I cannot directly mention, but for which security and being able to understand the content of documents is very, very important. So we are not working for any company out there, but for all those companies that have the problem of automatically understanding the content of texts and documents and exploiting them, because they have a lot of content. What are we doing for these companies? Well, we work in three main areas for which we deliver our products and solutions and projects. One is process automation, where we exploit our technology to create solutions that automate document flows, email processing, document processing, and publishing. And we automate these processes because volumes are so high that can't be managed by humans. Second area is knowledge discovery, where we work as a kind of search on steroids, where we can provide additional features and powerful features to deliver search and analysis applications for companies that analyze a lot of data. For example, as I mentioned, the intelligence area, where we have companies. By intelligence, I don't really just mean the classical intelligence, but also mean business-related areas like business intelligence per se, or competitive intelligence, market intelligence that companies do. The one final area is related to customer interaction or user interaction, where we have companies that provide our features to their customers, like search, personal assistants, and all this kind of facilitators in improving and extending the interaction with their customers and making it faster and more effective. Yeah, that's all about us, but what are we doing specifically in this research and scientific area at the moment? As I mentioned, we have been doing research for forever, basically. But what we are doing right now is both working with scientific and finance projects. So these typical projects that are maybe, for example, European projects that are very large ones, involving a lot of international partners, going from public organizations or universities to private companies that belong to the project and provide their needs and their work. So these are very complex projects for which we try to develop solutions that are not going directly to the market, but that they are testing and like proving the validity of the technologies that we've been working with. And they're not just academic work, but they are used and tested by important companies. Couple of examples in this area. For a large project, we've been working with these two important international companies, as you can see, and these companies themselves have been testing our solutions and new technologies, and have been very satisfied with the results, comparing them with other players that are available on the market, and getting very good results because they proved that our approach was definitely very effective. As you can see, both Philips and the Bosch group have been using and testing. They did this test. We didn't provide the numbers, but actually, as you see, they showed us that our approach was indeed very, very effective in these areas. We continue with this project. There's always new work for these projects, but we are also working in the pure academic area, where we try to where we have a specific scientific group. Well, in actually two separate groups that work with universities and the actual scientific research by providing, writing articles and trying to discover new important things about this area itself. This is just a selection of some of the articles that we recently authored and published in academic magazines and conferences. In particular, for a couple of them, I'm mentioning the ones I highlighted. I'm mentioning the fact that these two articles define new techniques for effectively managing AI technology, and they define specific solutions for sequence compression of tokens and for dictionary management for LLMs. And Meta, I mean Facebook, for those of you that are not familiar with the name, is using them because they cited us, and in one of their articles, they explicitly mentioned the fact that our techniques are the most effective for doing this kind of work, and they have been using that to train and create their own models. So that means that our discoveries are used by big players. Of course, they have got the resources to do all the experiments and tests that we cannot do. We can do all the tests for our inventions for small models, and they do the same thing with very large clusters of GPUs, and they can do the same for very large projects. But in fact, they are actually putting to work what we invent, and that we are, of course, proud for that. Okay, that's it. So let me now move to the LLM. We actually have to, we decided to customize and adopt. So the point is, why did we want to customize an LLM for a specific domain? First of all, we thought that at the time, that was the beginning of the LLMs a couple of years ago, we saw there was, the market was rapidly growing, but there was the need for in many cases for a number of features and characteristics for adopting LLMs that were hardly available by getting on the market and picking one. So we first of all, we thought, then is there a specific domain where we want to start and say, okay, for this domain, we want to have a custom large language model, which is not something that you can just get there and use. We started from one specific domain in general. The idea was, let's start with insurance, because insurance is because of a number of reasons. There's something specific with insurance that made it the best solution for us to start with. So first of all, we've been doing, as I mentioned, a lot of business with insurance, and we have a lot of insurance companies as customers, and so that made sense to have them test and adopt this new solution based on a custom LLMs. Secondly, the insurance industry is a bit different to most of other industries, because in most cases our customers are companies making anything, their own products or services, and as a side activity they have a lot of documents to deal with, and they use our technologies to deal with their documents or their customer documents or the documents they acquire, but the documents are not their products in most cases. Insurance is a specific industry where, in fact, what happens is that the companies, as a product, they produce documents, because policies are documents and claims are actual documents. So they produce documents for their customers, and they sell these policies, and they acquire claim documents. So the entire industry is based on money, of course, insurance prices and everything, but it's related to documents. So making sure that the content of these documents is entirely clear and understood, both when you write the policies and when you get claim documents from customers, is very, very important. Besides that, the insurance area has got a very specific language, or more than one language, because there's the insurance specific lexicon, but very often in claims there are also medical language for health insurance or this kind of this area, but not only, because for any kind of um, liability insurance, where we are dealing with accidents and any kind of bodily injury or whatever, there might be specific medical documents and records and everything. So there's a lot of medical language, and also legal language, of course, because it's not just finance and money, but there's a lot of any policy is a contract, so there's a lot of legal language, and these languages are very specific. They have a precise and complex lexicon, and being able to adapt and customize your solution to deal with these languages is very important. So we picked insurance, as I mentioned. One last point is that these documents very often contain personal and sensitive data. I mentioned health documents where it mentions, all the health information about users, but also financial information. So very often it's something for which customers might want not to use cloud services because they cannot send customer data and sensitive data across the cloud. So our ELMI is, first of all, the name. We wanted to create this model for insurance, and we call that ELMI. So it's an enterprise language model. That means that it's something that was created and is still evolved right now to work in the enterprise for customers, for our enterprise solutions. It's not something for the final user. It's not something that we sell for consumers. It's something for enterprise. And so what are the criteria to develop such a model? Well, first of all, there's a number of optimizations that we need to have for this model. We want to create an LLM that is customized and trained for insurance operations, for something that is useful for insurance companies to deal with. And they must be good for quality, of course, because if quality is not good enough, it's useless. So this is number one. Speed, so it must be fast, because it's, these models are in general expensive in terms of resources. So making it fast means that you can scale up quickly and save a lot of money in resources. By resources, I mean hardware, or anyway, GPUs, this kind of resources that cost a lot of money. It must be easy and effective when you do the training and tuning, and you need to change its behavior, and it must be usable in the operational area. So it must be able to do specific tasks that are useful for our projects and solutions. And then there's there's some number of constraints that we have. So the models that we acquire, that we use, and that we want to customize must have a valid license. So it's something that we need to be legally allowed to license, to use, to customize, and to license to our customers. And this makes the options a reduced number. It must be deployable or anywhere, like on the cloud, or on private cloud, or even on premises, on private machines in some server farm, or in customers' premises, because, as I mentioned, in some cases, our customers cannot afford to send their information out of their private cloud, or even a specific environment for security, for privacy of data and everything. And it must be able to integrate with our platform for insurance, because we do not want to deliver just an LLM, but solutions that exploit this LLM. And it must be something which is pretty much general purpose, because we want to use that for a lot of tasks across business cases. And we will start with that. Let's start with claims, where the volumes are higher. There's a lot of documents in claims, where people are sending millions of documents every day, and so we started with claims. So what we did was taking an existing model, and we did an initial selection of models, or more than one initial selection, a lot of selections. We are still selecting the best models out there that satisfy our constraints, and we do fine-tuning of those. So fine-tuning means that we want to have a model which is better than the base model where it comes from, at doing some specific activities. And for example, generically, the activities that we do are these three types. So one is zero-shot extraction. Zero-shot means technically that you are asking models to extract information from documents, like this is a claim document, extract me the claim number, the customer name, the policy number, what the customer is requesting, how much money is requesting as a compensation, and everything. But zero shot means that the model must be able to do this extraction without any example without being told, for example, this and that. So being able to do zero-shot extraction is something that has been very important for models since their inception some years ago, and it's something that now can be done, because zero-shot means that you can ask a model to extract, new and additional information without necessarily finding example to really show the model what you mean, because that can be even different across documents, and providing a sample is something which is always that can be problematic. One second point is summarization. Summarization in itself is one of the tasks that was historically impossible to perform in a general way, and the generative AI models made it possible. So we want to exploit, and we've been exploiting this feature, for a long time, and we are doing a lot of summarization for documents, because it's very important, and it delivers a lot of value for customers. So we want to teach this model to be able to summarize effectively. That means that does not just mean shorten the document, but it often means extract the most important points in the document, like in a bullet list, then summarize this in a couple of sentences, and then tell me these values. It is something which is very specific for the domain. One last point is being able to use a model to do question answering for RAG. I assume you might be familiar with what RAG is, because it was it was all the rage in 2024, but I'll be saying something more about RAG in a couple of slides later on. In general, the point is that we want to have a model that can be used in a question answering environment, for example, personal assistants and this kind of applications where it's very, very important. So we created a manually and automatically a data set for fine-tuning to teach a model and to train a model to be better at doing these things for insurance. So we created manual examples, and by examples I mean, for example, question and answer. So we are somehow tuning the model by telling the model, okay, here is a question and here's what I want as a perfect answer. And by providing not a lot, but some thousands of manually created examples, and then other artificially, so synthetically created examples, but always very specific, clean, deduplicated, with no personal data, no customer data, no sensitive data. So creating all these data sets ourselves allowed us to create very clean and effective data sets for the fine-tuning of the model. This data set is used to do the customization and also to do the test and evaluate different parts of the data set, also to evaluate the benefits in doing our customization. So what are we doing? Well, we are picking the best possible models out there, also according to the expected size and the necessary size, evaluate what are the best ones, and apply the customization to improve their behavior and make them suitable for the insurance industry. And that's what we do. I'm not showing the results that we obtain by this customization right now, because they are it's something that we are continuously improving and extending, but I show you some numbers about where we start from. So we are evaluating suitable models to select the best ones that we can use, but also the best models out there, even those that we cannot use for commercial reasons, for size, to understand what should we start from. And so this is a recent version of our benchmarking for LLMs out there. As you can see, there's a little bit of everything from commercial models like Claude 3.5 to GPT-4o, to open source models that we can use. Honestly, we are currently focusing a lot on Mistral Small, which is a model that is kind of compact and small and very fast with very good performance. As you can see, there's a range of different performance indicators that allow us to start from and to keep the LLM market and offer monitored, and to select, on a day. I'm not saying on a day-by-day basis, but we very often check again the market with new models and potentially change our baseline models, so the one that we use for customization. And as you can see, there's a very different value in the number of errors that these models do, from the best ones to the worst ones. Of course, that depends a lot on the size, but not only. Also, these models, when you want to do the tests, they have a very different price. But yeah, that's it. So this is just one, as an example, one of the statistics that we do continuously to create our ELMI model. So once we have this model, and this is something that improves over time, that we evolve, it's not a static model. How are we using it? Well, there's a lot of places where we want to use this model, but I show you a couple of examples of how a model can effectively improve the quality of LLM solutions. Well, first of all, one thing which is important to say is we do not give models directly to users. So we do not give users our chat GPT or something where they can play and ask questions. This is not something that makes sense in an enterprise environment. And so we use models and let users get the benefits of these models without users being able to directly talk to the model, let me say. So we constrain these models, our LME models, to only to work on, let me say, documents or texts that are submitted, but with prompts that are carefully controlled by us, and generating responses that are also controlled by us. And by us, I don't mean that we are physically there to check what happens, but that we create software components that check and combine and evaluate everything in the input and in the output, to make sure that what we send to the models is safe, and what the models generate is safe and reliable. So we also, let me say, combine the LLMs with our technologies and with other technologies, like the symbolic technology and the machine learning algorithms and everything, in a hybrid environment that lets us get the best of all the specific techniques. So where are as I said, where are the areas in which we want to make sure that the LLM adoption is safe? One is sending data to the LLM, and one is getting results from the LLM. So in terms of sending data, we want to control the prompts. So as I said, we want to do loose coupling of users and the model, so that we do not have users that can hijack the system and ask anything to models and do all the things that you can do with GPT, where you get like embarrassing responses. So we want to keep them separated and use them for the best of our enterprise results. In general, when we process documents, because as I mentioned, we often process documents and want to extract and get information from documents, not from user input. So we process documents, and we want to provide to these models relevant and structured information about documents, so that they can work at best and reduce the possibility of errors. We create prompts for these models that are in fact made of a context that is a document where we want something to be applied, and a task. So that means that we have a document, for example, a claim document, and a task that is extract the claim number, the policy number, the customer name, and the accident date from this document. That means that then we have an application create a prompt that combines the document and the request in a safe way, so that there's no way for documents to somehow hijack the behavior and get like a misdemeanor from the model. So this prompt control confines the behavior of the LLMs within the context itself, and reduces dramatically the possibility of hallucinations, which is, as I said, as everyone knows, one of the problems of the models. So on the outside, on the output part, the priority is reducing or removing as much as possible hallucinations. So we often check the response and the elements that it contains, numbers, entities, and we check if we believe that they could be generated from the input document. And if they couldn't, we believe that they were made up. Well, this is not an error, because the models can make up information and generate new information. But of course, it's something that needs to be checked, and the amount of made up information lets us raise potential alerts, or a red light that says, okay, pay attention, because there can be something that is not directly coming from the input, and so it might be dangerous. But the most important thing is that when we use these models, if we use them in a hybrid fashion, so combining the power of the LLMs with the symbolic technology, we reduce a lot the chance of getting bad content and the chance of getting hallucinations. Quick example on how we can do this kind of things. This is not exhaustive at all, but it's just a small example on what can be done. I think that it's easy to understand as a starting point. So the typical approach when companies are processing content from documents, like PDF documents, is you get a document, you do OCR, or extract the text from the document. You get plain text of the document content, which is the traditional way of doing this. And once you get this content, the text content of the PDF, you call the LLM, you send the whole document content to the LLM and ask, you provide requests in prompts, like this is a claim document, okay, a medical claim, and you say, okay, identify the patient name and the date of birth, list the past conditions from the medical history that is in this medical record, and summarize the latest diagnosis, and list me the drugs that are only those in the current therapy. Okay, that means that you are sending a very large, a potentially very large prompt to the model, and you ask multiple requests because you want to reduce the number of tokens. Every time you send a very large document, you are typically paying for the resources for the hardware or for the tokens. So you typically want to ask multiple questions to reduce the number of calls. This is kind of dangerous, because these models can now deal with very large contexts, or very large inputs, but this does not mean that the quality is uniform. The quality typically decreases with the size of input. So the larger is your input, the higher the chance of missing something, or getting worse results. So what are we doing instead? Well, first of all, we don't just do standard text extraction. We do intelligent IDP. So we transform the PDF in something which is a structured document that contains chapters, sections, tables, images. We understand exactly what the document is all about, and split that in relevant sections for which we know what the section is about. Like, for example, we know that there's a section whose title is past medical history and goes from page 27 to the half of page 32, and we can isolate that because we perfectly know where it is. And once we got this, and we know for each of these sections, we know what it talks about, what images, what tables are inside, the fact that the diagnosis is included in a larger section that is called current situation or something. So we know the hierarchy of titles. We know a lot about this document, so we can afford to use a different strategy with LLMs. So what we do is we just pick the single elements where the answer makes sense, and only send those elements to the LLM. So to get the same responses, to get like the patient name and date of birth, we only send like a short segment containing the personal data, because that's where the data is, and we do not want to have the risk that we get the wrong information from somewhere else in the document. The document is like 400 pages. We want to list the past conditions only from the past medical history, just to avoid that we get from somewhere else. For example, we want to list the drugs only from the therapy, because we don't want to have the drugs that the patient used to take, like 10 years ago in some condition that he had, and that is listed in the past medical history. And this is something that happened a lot with sending the whole document, because you get the drugs, so even those that were related to different conditions, we just send the current therapy, and so there's no way in which the model can find other drugs that were not in the current therapy. That's it. This is just a small examples to show what we're doing in this area. So now the point is, what benefits does this approach bring? Well, there are multiple benefits. In general, quality, because as I said, even best models out there are struggling with larger contexts, and the larger the context, the worse quality. So pinpointing content and only sending that content to the model is something that really improves quality. It reduces hallucination because it focuses the model on specific areas, and it also reduces the chance of getting off-topic responses, getting from the wrong source. It reduces dramatically the cost, because either you have the model on your machines and it save a lot of hardware, or you are calling someone else's model, even not using ELMI, you're using GPT or whatever. Well, you're saving a lot of tokens, and when your traffic is high, you have a lot of claim documents. Well, the cost is going to rise over time, and so saving tokens is very important. And it also improves performance, because you send small amounts of text and get small responses, and so lower resource usage, less latency, higher throughput. So there's a lot of benefits. So yeah, that's it. So how are we using this in example of applications? Well, let's talk, for example, about RAG. Okay. The point is that, as I said, we want to improve the quality of incoming documents with the approach that I just mentioned, with being able to extract parts of the document and be effective in sending that to the system. But then what are we doing with these documents? For example, a couple of things. One is creating data sets in general, like annotation of data sets, and what we call the hybrid RAG. The hybrid RAG, our RAG is retrieval augmented generation. It's like a search engine, a question answering on, which is was all the rage last year, and so I bet every one of you is aware of what the term means. But the RAG that we create is something which is a bit better. It's hybrid. So we acquire documents with a powerful way, we apply our technology in a powerful way, and we get better results. So how does our RAG work? Well, in general, it works with a combined approach for symbolic and neural technologies that concur to generate the best possible results. In general, we do both analysis for incoming documents and for user questions. So users are asking questions on their own documents. We process these questions with both the symbolic technology and the LLM, and we get results that are improving over the standard, over each one of those. So why does this improve the quality of results? Well, technologies have got different pros and cons. And in general, I would say that the symbolic technology is good at finding the exact elements and concepts and entities that you are talking about. So it is, the symbolic technology is concept driven. But on the other hand, the LLM technology is intent driven. So it's better at understanding when a part of a text is a potential answer to a user question. Okay, so users asking questions are going to get, using the symbolic approach, are going to get responses that talk about the right elements. Using the LLM approach, so the neural approach, they are going to get answers that are in the right form as an answer to this question. Combining these approaches is something that is better than any of the factors. So it's like the total is better than the sum of the combined factors, and allows us for a very good quality. So our question answering applications are something that also, as I mentioned, that also Philips and Bosch are testing, deliver the best possible quality, and also reducing dramatically the chance of getting false results and hallucinations. This is just an example of what we can do and what we are currently doing by combining symbolic technology with our ELMI LLM technology. Yeah, that's it, I guess. I said basically everything I wanted to talk about. Of course, if you have any kind of question or more information, if you want to learn anything about expert.ai, here's the information, so you can contact Andrew, and he'll also be able to show you a demo of the ELMI itself by using Australian documents. And yeah, that's it. So thank you, everyone.
Thank you, Nico.
I'll hand over to Andrew again.
Yeah, thanks. So just a couple of questions that came in. So the first one is, why didn't I see ELMI and Copilot in the benchmarking LLM results slide?
First of all, ELMI, it was not there because that was the starting point on how to create ELMI itself. So this is the kind of the survey that we continuously do to pick the best model to create ELMI. And so ELMI is indeed today one of those models. Well, not exactly. It's a customization of one of those models. And that the results that I showed you is that to show that we are continuously monitoring the market to pick the best ones. So ELMI is like one of those with the additional power. And there's also different stats for the evaluation of ELMI that were not shown today. As for Copilot, well, Copilot is not a model. It's an assistant. It's something made for users to do a lot of fantastic stuff, but it's not a model. It's got a model, an underlying model that can be called by API. Basically, I believe it's not disclosed by Microsoft, but I believe it's the underlying model is something based on GPT plus other models, because it does a lot of stuff. So a Copilot is like ChatGPT. It's not a model, it's an assistant. That is why it's not there.
Okay, so the last question is, can ELMI be ensured to comply with developing Australian regulatory compliance, auditability, and legal defensibility requirements?
Yeah,
Can be
this is
tailored for here.
this is a very delicate matter, because the regulations are evolving throughout the world, in Europe, in US, in Australia, I guess. So I'm not saying I'm completely aware of the Australian regulations. I'm not even completely aware. I guess almost nobody is for the European ones, because it's a very complex and delicate matter, and it's every day it's evolving. But in general, as I mentioned, yes, our technology using LLMs can be made, unlike most technology out there, can be made to be entirely accountable and explicable. So the explainability, sorry, the explainability of the results is something that we added on top of LLMs. So for every result you get with these LLMs, you can get very detailed information that tell you exactly where and why it got from specific documents and portions, and highlight the sentences exactly where it got the answers from, so it can be made explainable at any level. I'm not saying that this is enough, but this, combined with the fact that we pick open source known models and we only use controlled data to do the tuning, and so that our models are entirely safe in terms of the data contained, is a very good starting point to be compliant to present and future regulations, unlike many other models out there.
Okay, well, thank you, Nico. With some more questions, so might have ended there, and I'll just finish up by telling what's happening. Next event will be in March, on the 11th of March, and we're covering workers' compensation claim processing, so automating the processing workers' compensation claims. So if you're not involved in working compensation claims, but you think about complex bundles of documents that need to be analyzed and processed and summarized quickly. So that's what the March session's about. It's about understanding, complex packages of documents for processing. So we'll send out a link soon for that. And thank you, everybody.
Okay.
And,
thank you, everyone, for listening to me, and it was a pleasure to be here. Hope you enjoyed the webinar.
Thank you, everybody. Bye.
Okay. Bye-bye.
Where's the end button? There it is. Okay, bye.